Analytical Chemistry 1, Lesson 1. So welcome to Analytical Chemistry 1. I'm Professor Dan Thomas. I would like to start by looking at some common places and activities where analytical chemistry is being employed. Now we'll mention a few more during our first lecture, but to begin with, take a look at this picture. Do you know what this image is showing? It is a Google Maps image of a place here in the city of Guelph. Can you pick out anything familiar? Do the features you see suggest anything in particular? Yes, that is the Speed River flowing down the right side of the picture. What do you think those round things might be? I'll give you a hint. It has something to do with nice cold glasses of drinking water, and also with wastewater being discharged into a river. This is the Guelph Wastewater Treatment Plant located near where Highway 24 meets the Hanlon Expressway. Guelph is a city of about 140,000 residents. It uses more than 17 billion liters of water annually, drawn from 21 underground water wells. The drinking water is treated chemically and from some of the sites with ultraviolet radiation. All that water gets used throughout the city and then is passed through the sewers to this water treatment plant before being discharged back into the environment. The Guelph facility is a Class 4 water treatment plant, which operates under certification from the provincial government. They have a sophisticated analytical chemistry laboratory on site for testing water entering and leaving the facility, and to inform operations and to ensure compliance with environmental regulations. The lab is certified to ISO 17025 standards by the Canadian Association for Laboratory Accreditation. This is a copy of their current lab certification. Note the numerous chemical tests they are certified to perform. They have to ensure that the treatment operations control the levels of phosphorus and nitrogen oxides, ammonia and pH in the discharge flow, as the river heads down to Cambridge and onto Lake Erie. To obtain and maintain this accreditation, they implement standard laboratory methods that are described and promoted by the Standard Methods Organization, which is supported by several public health and environmental organizations. Their website provides access to several hundred detailed standard operating methods for the detection and quantitation of many organic and inorganic compounds found in the environment. The Guelph Wastewater Treatment Plant is one of the many places where analytical chemistry is an essential activity. To prepare you to work in such a facility is one of the goals of this course. So what is analytical chemistry? Well, it can be grouped into three general areas: separations, qualitative analysis, and quantitative analysis. Extracting a sample from the environment certainly would consist of many different chemical species. It is typical that experiments to detect and measure one particular chemical species is interfered with, both positively or negatively, by other species that are present. Being able to separate the species is a common requirement. Then the detection of if something is present, that's the qualitative analysis, and then how much of it is present, that's the quantitative analysis, are key steps the analytical chemist is engaged in. There are classical methods that should not be neglected. Precipitation and distillation are useful separation techniques, though more powerful chromatographic techniques are commonly used nowadays. In former times, chemists would detect substances by their observable physical properties, which could be as simple as the shape of the crystals they form or their melting or boiling points. Now we tend to employ more spectroscopic and microscopic instrumentation. Finally, electrochemistry, along with many spectrometric methods, present powerful tools for quantifying the amount of material present in a sample. This is analytical chemistry, and this course will help you to be prepared to use these tools effectively and intelligently throughout your future career.